Hey. Today we are going to be looking at 6.3, radicals and rational exponents. So it sounds pretty scary, but we're really just looking at this idea of a square root, of a cubed root, of a fourth root, and then a whole bunch of different other types of roots of numbers. So the first definition would be when b to the n equals a, so I have a number to an exponent equals something, for an integer n, so it's an integer exponent, which means it's a whole number exponent, the base is a root of a, right? So I have an nth root of a. Based on the exponent, it's an nth root. The nth roots of a number can be real or imaginary. The imaginary ones we're not going to worry about right now. You'll worry about those later. Now, what a root means, like when I say the square root of something, it's when you're looking for a number that multiplies by itself to equal that number, like the square root of 4. I'm looking for a number that when multiplied by itself 2 times, because the square root has a little 2 out here, we normally don't write it, but it's a number that multiplies itself twice to equal 4, and we know that's a 2. Also something like the square root of 9, a number that multiplies itself twice to equal 9, and that's 3. Now we're just going to look at some bigger ones, bigger numbers. I'm looking for the cubed root of 64, or the third root of 64, which means it's a number that multiplies itself 3 times because of this cube, or this 3 over here. So what's a number that multiplies itself 3 times to equal 64? That is tricky. It turns out that 4 times 4 times 4 equals 64. So the cubed root of 64 is 4, right? Because I know that 4 cubed equals 64. So there's a relationship here between these two expressions, that the cubed root of 64 equals 4, and that 4 cubed equals 64. Let's look at it again with an even bigger one, to the fourth root. The fourth root of 81. So that means I need a number that multiplies itself 4 times to equal 81. Perhaps 3 times 3 times 3 times 3. Right? 4 times multiplying itself. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is a 3, which means that 3 to the fourth should equal 81, and it does. That's again this relationship between these two equations. The fourth root of 81 equals 3, and 3 to the fourth equals 81. You're starting to see a little bit of a pattern there. Now, the nth root of a positive number a can be written as a power with a base a and an exponent of 1 over n. Now, that probably seems like a whole bunch of blah, 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 and who cares? What this means is that if I have a specific root of a number, like let's go back to a here, and I have the third root of 64, that can also be written as 64 to the 1/3. That's what this whole thing over here means. So if I have an nth root of any number, say it's an a, then that means that I can write it as a raised to the 1 over n. So that's why I can say when something is like the square root of 9, that's equivalent to 9 to the 1/2. Right? Or the fifth root of, I don't know, let's just say 64. That means I'm looking for 64 to the 1/5. All right, let's take a look at some examples where that type of thing is happening. I have 400 to the 1/2. Now the important thing that we need to recognize here is that raised to the 1/2, just like I did over here, is the same thing as the square root. So I'm looking for the square root of 400. Now, is it possible for me to actually find the square root of 400, or to at least be able to simplify that? And I think it should be, fairly easy. I could split this up, right? I might not know the square root of 400, but I do know that I can break this up into the square root of 4 times the square root of 100, right? So we know the square root of 4 is 2. Do I know the square root of 100? I do. It's 10. What's 2 times 10? 20. So that tells me that 20 times 20 should be 400. My solution for the square root of 400, or 400 raised to the 1/2 power, is 20. Let's try again with something else. B is 243 raised to the 1/5 power. Right, so again, the important thing to recognize here is that it's 243 raised to the 1/5 is the same thing as the 5th root of 243. So now, how do I manage to do this? Well, let's see, 243, it's got to be a number that multiplies itself 5 times. Okay, well, maybe it's had something to do with 3s or 9s. I mean, it's just, so let's try that out. I know that 3 to the 4th is 81. So what about if I tacked one more onto there? 81 times 3 is 243. So it turns out I'm looking at 3 times 3 times 3 times 3. That was 81 times 3 is 243. So the 5th root of 243 is a 3. Fantastic. Some of this, and I know that this can be very difficult for people sometimes, some of this is thinking through your multiplication, knowing numbers, and kind of just using the knowledge that you know about numbers to figure out what the root is. It's not so much follow these steps and you'll get the correct answer. Sometimes it requires a little bit more digging into knowledge that you already know. So it can be difficult. Alright, let's try these two now. It's a little bit trickier. Alright, what I have here is 16 to the 3/4. Now before, if I had something that said 16 to the 1/4, I know that that meant the 4th root of 16, and I was getting okay with that. I was working on it and it was okay. But now I'm saying I have 3/4, so it's not 1/4, it's 3/4. So the first thing I need to do is to split it up. 3/4 is the same thing as 3 over 1 times 1 over 4. Right? If I multiply those two numbers together, I would get 3/4. So can I do 16 to the 3rd? And do I know how to handle 16 to the 1/4? Yes, I do. So what this means is that it's going to be kind of the combination of two different things. Right? It's going to be the 4th root of 16, because of this 16 and the 1/4 here, but then that's also going to be cubed. Right? So what is the 4th root of 16? What number multiplies itself 4 times to get 16? Well, I can figure out that's a 2, but this 2 still needs to be cubed, so 2 cubed is 8. And that's how I would simplify 16 to the 3/4 power. Let's try that one more time with this 27 over here. The first thing I need to do is to split it up. 4/3 is the same thing as 4 over 1 times 1 over 3. Now this tells me that I have a cubed root because of this 1/3, so I want the cubed root of 27, but then I also need to raise that to the 4th power. So let's first worry about the cubed root of 27, a number that multiplies itself 3 times to equal 27. Well, that looks like it's going to be 3 times 3 is 9, times 3 is 27, so the cubed root of 27 is a 3. That still needs to be raised to the 4th power. Okay, so 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th is 81. And that is my solution here. Okay, very, very, very important that we recognize how to take these fractional exponents and split them up so that I can perform the right operations. Okay, you might be able to start getting into a shortcut where you see where the numbers are going to end up going, and that's okay. But we need to start by splitting them up, just to be sure that everybody is being careful. And we'll work on that a little bit more in class as well. Now let's look at our last example. The radius r of a sphere is given by the equation r equals 3v over 4 pi raised to the 1/3 power. So we're getting into some pretty complex equations here now, where v is the volume of the sphere. Find the radius of the beach ball to the nearest foot. Okay, alright, so I'm given some volume, and I want to figure out what the radius is. Luckily, I have a formula that tells me what the radius is. It's going to be 3 times the volume which I'm given is 1/13, and that's going to be over 4 pi, and then I believe all of this is raised to the 1/3 power. Very cool. So I'm definitely going to need a calculator for this probably, because I'm not going to be able to do the 1/3 or the cubed root is what this implies, right? Raised to the 1/3 power means cubed root. I'm not going to be able to do the cubed root of all of this stuff. 339 on the top over 4 pi. That's not going to be a nice even number that I'll be able to solve. So from here, I use my calculator to find the cubed root. And then what do I get? I get the radius equals, well, we'll do squiggly lines because it doesn't quite equal, it's just about. It's around 3. Okay? But the important thing to recognize here is that we use the formula, input the values, and then we can find the cubed root. And I can show you all how to do that on the calculators. It's just a very, very simple button. There's an actual cubed root or square root button on your calculator. And I think that's all. Alrighty. That is it for 6.3 radicals and rational exponents. We do have a lot of practice to do with this because, again, like all the things that we've been doing in Chapter 6 so far, it requires a lot of practice to get used to it. And write down any questions. We'll talk about them in class. Good luck on the work.